The Premier family of heaters is, I'd like to say, it's our bread and butter. It's our niche. It's the one product that we, although we have copycats in the industry now, it's the one product we do very well, we're very successful with. We created that technology, and the copycats that are out there just haven't done as good of a job. They do a good job, but not near as good of a job at efficiencies, at production, parts availability, heat transfer, all kinds of things that make them slightly inferior. But the Premier family of products, we took direct-fired technology. It's almost a derivative of our agricultural heaters in a way. You know, many years ago, you started getting concerns from insurance companies, safety inspectors, about having exposed flame and being able to touch fire on a job site. And they wanted to kind of take any kind of combustion flame exposure and contain it. Where, you know, in direct-fired heat, you can't do that historically. You know, you turn this product on, you've got a big roaring flame in there that's shooting out. And although we can control our flame output, you know, with that pitted plate in the back of it with all the holes in it and stuff, helps us to control the burn pattern, that we can take that flame and bring it, you know, far back into the chamber to control it. It's still there. Competitive models, especially ones that are true salamanders and not mechanically supported, you've got flame flickering and shooting out the end of these units. So we took the same direct fire technology and we took that combustion and we put it inside of an encased combustion chamber. Still direct fired, and I should comment, we talk about direct and indirect just to make sure everyone understands. When we talk direct fire, when we talk direct fire, the air that you're heating, the air that you're putting out into your environment comes in direct contact with the combustion process. So you bring air in, it touches flame, it therefore captures contaminants, carbon monoxides, ethylenes, other byproducts, and it sends that byproduct out into the environment. It doesn't mean it's unhealthy or unsafe. However, direct fire heat does need fresh air exchange to do two things: help displace those contaminants, but also help replace oxygen that the unit's consuming. When we talk indirect fire, that combustion, that's where you see units with a chimney, that combustion is happening completely enclosed inside of a combustion chamber that comes in no exposure whatsoever with the air flowing through the unit, therefore venting all your byproducts out the chimney, so your air coming through is pure, clean, dry, breathable air. So at this time, when the market said, and you know, safety concerns were, hey, we want to eliminate, you know, fire opportunities on job site, we want to enclose our combustion chamber, a lot of the market started moving over in indirect fire heat because it's completely enclosed. You can't touch it, you don't come in contact with it. It was probably the right path, but now you've got customers buying a product that does cost a lot more money. It's a lot less efficient than direct fire heat. Therefore, you're wasting a lot of money in heat output. But what we did with the Premier heater is we said, hey, we can take a direct fire unit, we can encase that combustion chamber, still have it direct fire, air comes over, comes out, collects contaminants, goes out the other side. However, by encasing it all and having the squirrel cage centrifugal fan system that we did, we can move a lot more air over that system and take that heat out into the environment without having any of that flame exposure and eliminating all those safety concerns. With that, with the addition of the centrifugal fan, we're getting a lot more air volume and they're able to throw air a lot further and able to do so at a much lower temperature. So when I talk about this unit, you know, apples to apples in a 400,000 BTU model, this unit's producing 800 degrees Fahrenheit, roughly, in a very intense heat. We're spinning it out, you know, 10, 12 feet, 15 feet on a good day, and we're dissipating it upwards quickly, relying on reverse convection or fans or some kind of support to keep it down. This unit here will produce heat at 130 degrees above ambient. So much cooler. I mean, if it's 30, 40 degrees out, you're producing heat at 170, 180 degrees. You're putting out the same amount of BTUs, close enough, 350 versus 400, but much lower temperature. So remember, it's the BTUs that counts. So by producing a much lower temperature, we're able to put a lot more air behind it. We're able to push that heat a lot further out to our environment. This unit here, you can walk out 35, 40, 45 feet and still feel your pant legs moving. So now we're throwing out a lot further. And because of the lower temperature, we're also now able to force that air down to the ground. You notice all these units are angled upward, which is a design requirement because it's so intense. We're going to get that heat slightly up off the ground. This unit, the way that squirrel cage fan comes out, we're forcing air down. So now we're coming down, out, and we're doing so at a rate where we're constantly turning air over top of itself, and therefore keeping all that heated air in the environment a lot longer, creating a heck of a lot more efficiencies. And that's why we refer to that as an environment heater as opposed to a space heater. So dollar for dollar, you get a lot more space with a premier heater. It's also ductable. It's called ductable unit heaters. You cannot put ducting on any traditional direct fire heaters because of that temperature. It's just so intense at 800 degrees that there isn't, I mean, I'm sure you can find a duct out there, but you'll never get it certified. You know, with these units at much lower output, now we can actually run the units outside, duct them in, run ducts down hallways, do whatever you need to do. But they are ductable units. I covered most of this in going through it, but talk about heat transfer. It's still mechanically supported. There's a fan behind it, but again, centrifugal fan as opposed to axial fan. So a squirrel cage as opposed to a propeller. We're just able to get a lot more volume for applications used in any environment where ducting is required. It actually promotes accelerated drying. And when we say drying, it's more remediation than it is dehumidification. That Premier 80, geographically our largest market is Canada, and our largest market segment is the drywall industry. There's a lot of science and technology behind direct-fired heat that says direct-fired heat produces moisture, which it does. But with these units specifically, I don't know if you're going to say, it's very difficult for me to explain, but it comes down to air volume. We're able to move so much air at a rate that allows us to move heat, recirculate heated air at a rate faster than the heater can actually, it allows the air to hold more moisture at a rate that's quicker. It'll hold more moisture than the heater can produce. I guess that's the simplest way of saying it. So although this is producing so much moisture, we're turning so much air at a rate that it wants more moisture than the heater can produce. So what it naturally does is it pulls moisture from drywall, concrete, and that's that remediation effect. You still need a way to get moisture out of the environment. So the drywall industry, you know, they're running these. They still have fans and some windows and stuff like that. You're not even get that moisture out. But it'll accelerate drying in drywall, as an example, quicker than a dehumidification system. Very, very ideal for rental operations. It's safe. It's very efficient heat. Although we're going to go through them technically, we almost call them maintenance free. There's very, very little that goes wrong with them. The stuff that does go wrong is very simple and things that are commonly overlooked. But the rental companies that were very successful rental-wise, rental companies we deal with are extremely happy with that kind of product because it takes them out of the day-to-day technical troubleshooting. The models available you see up there, so our 80, our 170, and our 350, again, all output-wise. Today, the models, you know, this is an older slide. We used to have, in the 80, it was either available in a propane or a natural gas model. As you see there, this is brand new. I think the first shipment may have went out just last week. So brand spanking new is that the 80 is now available in a dual fuel system. And then the 170 and 350 have been for quite some time. Historically available in propane, natural gas, or dual fuel on those models. The evolution of the product will see the natural gas model discontinued. So it'll be a propane or a dual fuel, because very rarely are they used solely on natural gas.
Just to make everybody aware that when we're talking dual fuel, you take propane or natural gas, there's a little selector valve located between the gas and fuel valve of the burner. You just position the selector valve to whatever fuel you're going to be using. Past heaters like LP or natural gas, you had to make a gas conversion. Yes, a little bit time, constraints on it and so forth. But dual fuel, I think, is the best way to go on these heaters. You don't have to worry about gas conversion.